Picture the scene in the freezing waters off the coast of Northern Ireland in late 1945. You are looking at a ghost fleet of 116 surrendered German U-boats, the very same steel sharks that sent thousands of Allied sailors to a watery grave and nearly starved Great Britain into submission. These submarines represent the absolute pinnacle of naval engineering of their time, including the terrifying Type XXI, a vessel decades ahead of anything the United States or the Royal Navy had in the water. Yet, instead of integrating these technological marvels into our own fleets, the Allies made a cold, calculated decision to drag them out into the deep Atlantic and blow them to pieces. Welcome back to the channel, where we dissect the brutal realities, the hidden logistics, and the ruthless tactical decisions of military history. If you want to understand the raw mechanics of warfare and the geopolitical chess moves that shape our world, make sure you hit that subscribe button and turn on notifications. I want to hear from you in the comments down below regarding a massive strategic dilemma. If you were sitting in the Oval Office or at 10 Downing Street in 1945, I want to know if you would have ordered the destruction of the most advanced submarine fleet on Earth, or if you would have risked a diplomatic war with the Soviet Union to keep them for yourself. To understand the sheer scale of Operation Deadlight, we have to strip away the myth and look at the cold, hard logistics of the post-war naval landscape. On May 8, 1945, Nazi Germany unconditionally surrendered, bringing the European theatre of the Second World War to a close. The guns fell silent across the devastated continent, but out in the Atlantic Ocean, a massive, highly lethal and fully armed submarine fleet was still lurking beneath the waves. Grand Admiral Karl Dönitz, who had briefly succeeded Adolf Hitler as the head of the German state, issued a final, bitter order to his surviving U-boat commanders. He ordered them to surface, hoist black flags of surrender, transmit their positions in plain language, and proceed to designated Allied ports. Over 150 U-boats complied with this order, limping into harbours like Lisahally in Northern Ireland and Loch Ryan in Scotland under heavy Allied escort. Suddenly, the British and the Americans found themselves babysitting a massive arsenal of enemy warships. But this was not just a matter of disarming a defeated foe, because this was the opening move of the Cold War. The alliance of convenience between the United States, Great Britain, and the Soviet Union was already fracturing before the ink on the surrender documents was even dry. At the Potsdam Conference in July 1945, Soviet Premier Joseph Stalin made his demands crystal clear to the Western Allies. The Soviet Union had bled heavily to defeat Germany on the Eastern Front, losing millions of men, and Stalin wanted his cut of the industrial and military spoils. Specifically, he demanded 1/3 of the surviving German navy, which included a massive chunk of the captured U-boat fleet. For President Harry Truman and Prime Minister Winston Churchill, handing over advanced German submarines to the Red Navy was a strategic nightmare that had to be avoided at all costs. We have seen this kind of naval paranoia before, and the historical precedents heavily influenced Allied thinking during the summer of 1945. Look back to the end of the First World War in 1919 for a perfect example of how captured fleets create geopolitical chaos. The victorious Allies interned the mighty German high seas fleet at Scapa Flow in Scotland, debating for months over how to divide the battleships and cruisers among the French, the British, and the Americans. The German commanders solved the problem for them by secretly scuttling their own fleet, sinking 74 warships in a single afternoon, while the British guard ships were out on exercise. The British learned a hard lesson that day about the dangers of keeping an intact, fully functional enemy fleet sitting in your own backyard, while politicians argue over its fate. You also have to compare the logic of Operation Deadlight to the logic of Operation Paperclip, which was happening at the exact same time. After the Second World War, the United States military aggressively recruited German rocket scientists, aerodynamic engineers, and medical researchers. We gladly took Wernher von Braun and his V-2 rocket team into the United States because ballistic missiles were the unwritten future of strategic strike capabilities. So why did we save the rocket scientists but decide to drown the submarine fleet? The answer lies in the immediate tactical threat profile. Rockets were experimental and years away from being a reliable intercontinental threat. But submarines were a proven, highly effective weapon of economic strangulation. The United States Navy and the Royal Navy already had massive surface fleets and perfectly adequate diesel-electric submarines for the Pacific theater operations. What they did not have was a desire to see the Soviet Union reverse engineer the most advanced German submarines and mass-produce them in Russian shipyards. Giving the Soviets advanced U-boats would instantly negate the massive surface fleet superiority the United States had built during the war. It was a brutal but simple equation for the Allied commanders. If we could not keep the U-boats without being legally forced to give a third of them to Joseph Stalin, then nobody gets them. Let us break down exactly what the Allies were dealing with in this captured fleet, because this was not just a monolithic group of identical, outdated submarines. It was a diverse ecosystem of underwater killers, representing the entire evolutionary tree of German naval doctrine and engineering. The bulk of the surrendered fleet consisted of the Type VII, which was the absolute workhorse of the Kriegsmarine and the backbone of the Wolfpack doctrine. A Type VII displaced about 870 tons, submerged, and measured 220 feet in length. It was powered by two supercharged Germania-Werft four-stroke diesel engines, generating up to 3,200 horsepower on the surface, alongside two electric motors for underwater propulsion. It had a maximum surface speed of 17.7 knots and a sluggish submerged speed of only 7.6 knots. Its true lethality lay in its armament, carrying 14 torpedoes fired from 4 bow tubes and 1 stern tube. These were not just standard straight-running torpedoes, because by 1945 they were equipped with acoustic homing torpedoes like the T5 Zaunkönig, specifically designed to lock onto the propeller noise of Allied escort destroyers. The Type VII had a crush depth of over 750 feet, allowing it to dive deep into thermal layers to evade depth charges. But for all its historical success during the early years of the war, the Type VII was essentially a surface torpedo boat that possessed the ability to submerge for short periods to attack or hide. Against late-war Allied radar and air cover, the Type VII was completely obsolete and highly vulnerable. Then you had the Type IX U-boats, which were the heavy, long-range oceanic cruisers of the German fleet. Displacing over 1,200 tons, submerged, the Type IX was designed to project German naval power far beyond the North Atlantic and into the deep waters of the globe. These were the boats that executed Operation Drumbeat in 1942, slaughtering unprotected American merchant shipping right off the eastern seaboard of the United States, from New York down to Cape Hatteras. They had a phenomenal operational range of over 30,000 miles when cruising at 10 knots on the surface, allowing them to operate in the Indian Ocean or off the coast of South America without needing to refuel. They carried 22 torpedoes and were armed with a heavy 105mm deck gun to finish off crippled freighters without wasting precious torpedoes. But the real prize, and the primary reason Operation Deadlight had to be executed with extreme prejudice, was the Type XXI, commonly known as the Elektroboot. This specific class of submarine fundamentally changed naval warfare forever and served as the direct ancestor to modern submarine design. Before the Type XXI, submarines were essentially surface ships that could dive to escape detection. The Type XXI was a true submarine, designed from the keel up to operate entirely underwater for the duration of its patrol. It displaced 2,100 tons submerged and was 250 feet long, featuring a streamlined, hydrodynamic hull completely devoid of deck guns or external clutter. The absolute game-changer was its massive battery capacity, which was 3 times larger than the battery banks found on the Type VII. Combined with its sleek hull design, the Type XXI could achieve a staggering underwater speed of 17.5 knots. For tactical context, most Allied anti-submarine corvettes and frigates could barely make 16 knots on the surface in rough seas. This meant the Type XXI could literally outrun its surface hunters while completely submerged. It also featured a revolutionary hydraulic torpedo loading system, allowing the crew to reload its 6 bow tubes in less than 20 minutes, a grueling process that took hours of manual labor on older boats. Furthermore, it was equipped with a snorkel mast, allowing it to run its diesel engines and recharge its massive batteries while remaining submerged at periscope depth, hiding it from airborne radar. The sonar and radar warning receivers on the Type XXI were highly advanced, including the Balcon Great passive sonar array, which could track target convoys from over 30 miles away without ever raising a periscope. If the Soviet Union got their hands on a fleet of Type XXIs and successfully reverse-engineered them, the United States Navy would have faced an insurmountable anti-access and area denial threat in the North Atlantic during the opening days of the Cold War. Facing this German technological marvel was the overwhelming industrial, logistical, and tactical juggernaut of the United States and Great Britain. The Allied anti-submarine warfare doctrine had evolved from a desperate reactionary defensive posture in 1940 into a highly aggressive, technologically superior hunter-killer network by 1945. The United States industrial base, led by visionaries like Henry Kaiser, was churning out Liberty and Victory cargo ships at a rate that mathematically broke the back of the German tonnage war. At peak production, American shipyards were launching a new Liberty ship every single day, welding hulls together faster than the steel could cool. You simply cannot win a war of attrition against an industrial powerhouse that builds ships faster than your entire submarine fleet can sink them. But it was not just about flooding the ocean with merchant hulls, because the Allies fundamentally revolutionized the tactical battle space above and below the water. We deployed escort carriers, which were small, mass-produced aircraft carriers built on commercial merchant hulls, effectively closing the mid-Atlantic air gap where U-boats used to hunt with impunity. These carriers launched Grumman TBF Avenger torpedo bombers and F-4F Wildcat fighters, providing constant lethal air cover for the convoys. The sky was filled with consolidated B-24 Liberators, modified for very long-range maritime patrol and painted in anti-submarine white camouflage. These heavy bombers carried centimetric radar that could detect a U-boat periscope or snorkel in the dead of night, stripping away the U-boat's greatest asset, which was the cover of darkness. The surface escorts, primarily the American destroyer escorts and the British River-class frigates, were armed with high-frequency direction-finding gear, known as Huff-Duff, which instantly triangulated the radio transmissions of the wolf packs. When an Allied escort located a U-boat, they did not just blindly drop standard depth charges off the stern anymore. They used the Hedgehog, a forward-throwing mortar system that fired a spread of 24 contact-fused projectiles ahead of the ship, directly over the sonar contact. Unlike traditional depth charges, which exploded at a preset depth and completely disrupted the sonar picture with underwater turbulence, Hedgehog projectiles only exploded if they physically struck the steel hull of the submarine. If the sonar operator heard an explosion, you knew you had a confirmed kill. The United States also deployed the Mark 24 Fido, a highly classified air-dropped acoustic homing torpedo that would actively hunt down a submerged U-boat by listening for the cavitation noise of its propellers. The technological gap had completely closed and then violently swung in favor of the Allied forces. Does it really make tactical sense to build a better mousetrap if the mouse has already starved to death on the battlefield? By the time the revolutionary Type XXI was finally ready for mass deployment, the German industrial base was a smoking crater, pounded into rubble by the relentless daylight bombing raids of the American 8th Air Force and the nighttime area bombing of British Bomber Command. The U-boat pens in France had been captured, the construction yards in Bremen and Hamburg were destroyed, and the logistical supply chains were entirely severed. The surviving U-boats had no diesel fuel, no safe operating bases, and practically no experienced veteran crews left to man them, as the casualty rate for German submariners hovered around an appalling 75%. The Allies had decisively won the Battle of the Atlantic through sheer brute force logistics, rapid technological iteration, and overwhelming industrial capacity. But the sudden surrender of the U-boat fleet presented a massive logistical and political headache for the victorious powers. 116 heavily armed, highly complex, and rapidly deteriorating submarines were now sitting idle in British ports, taking up valuable dock space. They were packed with unexploded ordnance, leaking corrosive battery acid, and filled with highly toxic torpedo fuel that posed a constant hazard to the harbour crews. Maintaining these captured vessels was costing the exhausted British taxpayer an absolute fortune at a time when the country was virtually bankrupt. Guarding them required thousands of trained naval personnel who were eager to be demobilized and sent back home to their families. And every single day these boats sat in port, the Soviet diplomats grew louder and more aggressive in their demands for their rightful share of the prize. The Tripartite Naval Commission eventually agreed that a very small number of the most advanced boats would be divided equally among the United States, Great Britain, and the Soviet Union for strict technical evaluation. The United States took a few Type XXIs back to American shipyards to study their hull designs and battery configurations, which directly influenced the design of the post-war Tang-class submarines, and ultimately paved the way for the Nautilus nuclear submarine program. But the rest of the fleet, the vast majority of these dangerous steel coffins, had to be permanently erased from the board before they could cause any more diplomatic friction or fall into the wrong hands. The political mandate from the highest levels of the Allied command was absolutely clear, but the tactical execution of this order was an absolute nightmare waiting to happen. You do not just pull a plug on 116 heavily armoured submarines and casually watch them sink to the bottom of the harbour. These vessels were built with highly compartmentalized pressure hulls, heavily reinforced with high tensile steel, specifically designed to withstand the crushing depths of the deep ocean and the concussive shock waves of heavy depth charges. They were over-engineered by German shipbuilders to stay afloat under extreme duress and massive structural damage. To officially sink them, the Royal Navy would have to tow these dead, unpowered metal tubes hundreds of miles away from the coast, dragging them through some of the most treacherous, storm-battered winter seas on the planet. They had to execute this massive towing operation while dealing with exhausted skeleton crews, snapping tow lines in gale-force winds, and the constant, terrifying threat of accidental ordnance detonation inside the hulls. The final destruction order was given, the deep-water target grids were drawn off the coast of Ireland, and the executioners loaded their naval guns and prepped their demolition charges. But as the first heavy steel tow lines were attached in the freezing, relentless rain of late 1945, the Allied sailors were about to discover that killing a U-boat, even a fully surrendered and disarmed one, was never an easy task. Dragging a dead 2,000-ton steel cylinder through the North Atlantic in the dead of winter is a logistical nightmare that defies basic seamanship. When a submarine has no engine power, it has zero forward momentum to punch through the ocean's swells, meaning it simply wallows in the trough of the waves, acting as a massive, erratic sea anchor. Without the gyroscopic stability provided by a spinning propulsion shaft, and without the ability to use its diving planes to stabilize its trim, a surrendered U-boat on the surface will roll violently, sometimes snapping up to 45 degrees in heavy seas. This was the brutal physical reality facing the Allied naval crews tasked with executing Operation Deadlight. The target zone was a deep-water grid located approximately 130 miles northwest of Lough Foyle, Ireland, where the ocean floor drops into an abyssal trench over 3,000 feet deep. To get the Ghost Fleet to this graveyard, the Royal Navy, alongside Allied Polish destroyers like the ORP Błyskawica and the ORP Krakowiak, had to physically tow 116 submarines through some of the most treacherous, storm-battered waters on the planet. The operation officially commenced in late November 1945, and the timing could not have been worse. The North Atlantic in November and December is a relentless meat grinder of low-pressure systems, generating gale-force winds that routinely hit 8 or 9 on the Beaufort scale. Air temperatures plummeted into the low 20s Fahrenheit, while the freezing ocean spray instantly turned to thick ice the moment it struck the steel decks and gun mounts of the towing destroyers. Have you ever tried to drag a rusted, unpowered vehicle through a blizzard using a single, rigid metal wire, while both of you are sliding on black ice? That is exactly what the Allied destroyers were attempting to do with heavy steel towing hawsers. To keep the dead submarines from yawing wildly and snapping the tow lines, the Royal Navy was forced to place skeleton prize crews aboard the U-boats. These small boarding parties, usually consisting of a junior officer and a handful of exhausted enlisted men, had the most dangerous job in the entire post-war Navy. They had to stand on the rotting, slippery wooden deck casings of the U-boats, completely exposed to freezing waves crashing over the conning tower, just to manually tend the towing gear and attempt to hold the rudimentary helm steady. Inside the boats, it was even worse. There was no electrical power, meaning no heat, no lights, and no ventilation. The interior of a Type VII or Type XXI U-boat that had been sitting idle in port for 6 months was a toxic nightmare. The massive lead-acid battery banks, located beneath the deck plates, were slowly leaking, releasing highly explosive hydrogen gas and suffocating chlorine fumes into the stagnant air. The prize crews had to navigate these pitch-black, freezing, fume-filled iron tombs using only handheld flashlights, constantly listening for the terrifying sound of groaning steel that would indicate a breached pressure hull. If the tow line snapped in the middle of a winter storm, these men were entirely trapped on an unpowered, sinking vessel, with absolutely no way to call for help. The sheer physical strain on the towing equipment was catastrophic. In heavy seas, a destroyer will crest a massive 40-foot wave just as the U-boat it is towing slides down into the deep trough behind it. This creates thousands of tons of instantaneous shock loading on the tow cable. Despite using heavy steel hawsers connected to thick anchor chains designed to act as a shock-absorbing spring, the cables began snapping like cheap guitar strings. When a tow line parted with a sound like a cannon shot, a heavy steel whip would violently lash back toward the destroyer, capable of cutting a sailor in half, while the U-boat would immediately drift away into the fog and darkness. By the second week of December 1945, the towing operation had devolved into complete chaos. Out of the 116 submarines designated for destruction, 54 of them foundered and sank prematurely because the towing cables snapped and the brutal Atlantic storms simply battered the unpowered hulls until their buoyancy tanks flooded. The destroyers spent days desperately hunting down these drifting, highly dangerous derelicts on surface radar before they could pose a navigational hazard to civilian merchant shipping. When a U-boat successfully made it to the designated deep water grid, or when a drifting boat was finally hunted down, the execution phase began. The primary tactical plan was elegant but highly dangerous, requiring demolition experts to board the submarine and plant scuttling charges. Royal Navy armourers used 4-pound blocks of high explosives, typically Torpex or TNT, wired with timed fuses. These charges were placed directly against the internal pressure hull, specifically targeting the main engine cooling water intakes and the torpedo loading hatches, which were the structural weak points of the vessel. Once the fuses were lit, the demolition team had exactly 3 minutes to scramble up the vertical ladders, jump onto a small inflatable dinghy tossing in the freezing swells, and row frantically away before the charges detonated, blowing the bottom out of the submarine and sending it plunging to the abyss. But as the weather deteriorated and the seas became too violent for small boat transfers, boarding the U-boats to plant explosives became a suicidal impossibility. The Allied commanders were forced to pivot to their secondary method of execution, which was raw, unadulterated naval gunfire. Sinking a submarine with surface gunfire sounds simple on paper, but in practical application, it is a highly complex ballistic challenge. Look back at the Battle off Samar in 1944, where American destroyers and destroyer escorts had to fire point-blank at massive Japanese cruisers in heavy seas, struggling to keep their optical rangefinders locked onto targets while their own ships were violently pitching and rolling. The British and Polish destroyers in Operation Deadlight faced a similar gunnery nightmare, but their targets were much smaller and infinitely more stubborn. The standard weapon of the British fleet destroyers was the 4.7-inch naval gun, firing a 50-pound high explosive or semi-armor-piercing shell at a muzzle velocity of over 2,600 feet per second. However, a U-boat is explicitly designed to present the smallest possible silhouette on the surface. Only the conning tower and a few feet of the curved upper deck casing remain above the waterline. Furthermore, the inner pressure hull of a German U-boat was constructed from high-tensile Krupp steel, up to 1.1 inches thick, specifically engineered to withstand the massive concussive shock waves of heavy depth charges and the crushing hydrostatic pressure of deep dives. When the destroyers opened fire, they quickly realized that hitting the upper deck casing or the conning tower did absolutely nothing to sink the boat. The shells would either pass cleanly through the thin, unpressurized outer sheet metal, or they would strike the curved, cylindrical shape of the inner pressure hull and violently ricochet off into the sky. Why waste hundreds of rounds of precious naval ammunition shooting at a target that refuses to sink? Because a floating, abandoned submarine is a massive, unlit mine waiting to be struck by a passenger liner. To actually kill the U-boat, the destroyer gunners had to wait for the exact moment the U-boat rolled on a wave, exposing the vulnerable waterline, and then punch a shell directly through the main buoyancy tanks and into the pressure hull below the surface level. It was an agonizing, time-consuming process. The destroyers would circle their prey like wolves, firing dozens of rounds in freezing rain, watching explosions spark and flash against the German steel. The advanced Type XXI submarines proved to be exceptionally difficult to kill. Their streamlined hydrodynamic hulls lacked the flat surfaces and external clutter of the older boats, making them incredibly resistant to structural compromise from gunfire. In several instances, destroyers expended over half their magazine capacity just to put a single Type XXI under the waves. When naval gunfire proved too slow, the Allies brought in the heavy hitters of the Royal Air Force Coastal Command and the Submarine Service. This operation was not just a disposal effort, it was a live-fire training exercise of unprecedented scale. Short Sunderland flying boats and heavily modified B-24 Liberator bombers roared over the target grids, using the tethered U-boats for target practice. They dropped airborne depth charges and unleashed salvos of unguided RP-3 air-to-surface rockets, the same 60-pound rockets that Hawker Typhoons used to crack open German Tiger tanks in Normandy. The rockets would tear through the U-boat pressure hulls, instantly flooding the compartments and sending them to the bottom in a boiling cauldron of white water and leaking diesel fuel. The Royal Navy also deployed their own submarines, such as the HMS Tantivy, to execute the German boats using live warshot torpedoes. Firing a 21-inch Mark 8 torpedo packed with over 700 pounds of Torpex high explosive into a stationary U-boat provided devastating results. The concussive shockwave of a direct torpedo hit would physically snap a Type VII U-boat in half, throwing massive chunks of jagged steel and debris hundreds of feet into the air. It was a violent, spectacular end for the machines that had terrorized the Atlantic, but the process was grueling, dangerous, and exhaustively slow. Day after day, week after week, through the bitter winter of 1945 and into the early weeks of 1946, the Ghost Fleet was systematically dragged out and slaughtered. The men executing the operation were exhausted, freezing, and operating on the absolute ragged edge of their physical endurance. They were fighting a war against the weather and the stubborn, over-engineered resilience of German naval architecture. The ocean surface was constantly slick with highly toxic torpedo fuel, battery acid, and thousands of gallons of heavy diesel oil bleeding from the ruptured hulls of the sunken fleet. The sheer volume of destruction was staggering, with over 116 submarines representing hundreds of thousands of tons of advanced metallurgy and lethal machinery being violently erased from existence. But as the final U-boat slipped beneath the freezing waves, leaving nothing but an oil slick and floating debris on the surface of the Atlantic, the strategic reality of what the Allies had just done began to set in. The ocean floor was rapidly becoming a highly concentrated graveyard of the Third Reich's greatest technological achievements. But the sheer volume of sunken steel and the toxic payloads hidden inside those crushed hulls were about to create an entirely new, deeply classified problem for the post-war world. The sudden creation of a massive, highly concentrated underwater graveyard of advanced military hardware immediately generated a completely new set of long-term strategic consequences. Down in the freezing, pitch-black depths of the North Atlantic, over 3,000 feet below the surface, 116 German U-boats now rested in the abyssal mud. They were not empty, hollow shells, because they went to the bottom fully loaded with a highly toxic cocktail of heavy metals, unexploded ordnance, and experimental chemical compounds. Many of these submarines were carrying hundreds of pounds of elemental mercury, which was utilized as ballast and in the intricate gyroscopic guidance systems of their acoustic torpedoes. They were loaded with thousands of gallons of specialized, highly corrosive diesel fuel and decaying lead-acid batteries that would slowly leach into the marine ecosystem for the next 80 years. But in the winter of 1945, environmental concerns were absolutely non-existent in the minds of the Allied High Command. The only pollution they cared about was the ideological pollution of the Soviet Union, spreading across a devastated Europe. By violently erasing the U-boat fleet, the United States and Great Britain successfully executed a massive geopolitical denial-of-service attack against Joseph Stalin. The Soviet premier was absolutely furious when he realized the Western Allies had deliberately destroyed the lion's share of the prize. But the tactical reality was that the Red Navy was temporarily crippled in its ability to immediately challenge American dominance in the Atlantic. How do you put a price tag on global stability when the currency is measured in sunken steel and diplomatic outrage? We often look at the deliberate destruction of functional military hardware as a catastrophic waste of taxpayer money and engineering potential. But history proves that geopolitics frequently demands the sacrifice of your own assets to maintain the balance of power. Look directly at the Washington Naval Treaty of 1922 for the perfect historical precedent to Operation Deadlight. After the First World War, the United States Navy was in the middle of a massive shipbuilding program, constructing some of the most powerful warships ever conceived. One of these was the USS Washington, designated BB-47, a massive 32,000-ton Colorado-class battleship armed with 8 devastating 16-inch guns. She was over 75% complete, representing millions of dollars of American labor and raw materials. Yet, to comply with the strict tonnage limits of the International Arms Limitation Treaty and prevent a global naval arms race with Great Britain and Japan, the United States towed this brand-new, state-of-the-art battleship out into the Atlantic Ocean in 1924 and deliberately sank her as a gunnery target. Why would a superpower destroy its own apex predator? Because the strategic value of preventing a global arms race vastly outweighed the tactical value of one single battleship. Operation Deadlight applied this exact same brutal, cold-blooded calculus to the captured German U-boats. The strategic value of keeping the Type XXI technology out of mass Soviet production vastly outweighed the scientific value of keeping the fleet intact. You can also see this ruthless logistical logic mirrored decades later during the chaotic final days of the Vietnam War. Think about the iconic, heartbreaking footage from the flight deck of the USS Midway during Operation Frequent Wind in April 1975. American sailors and Marines were physically pushing perfectly functional, multi-million-dollar UH-1 Huey helicopters over the edge of the aircraft carrier, watching them smash into the South China Sea and sink to the bottom. Was it a waste of valuable aviation assets? Absolutely not, because it was a rapid, calculated destruction of hardware required to clear critical deck space for incoming Cessna 01 bird dogs and more helicopters packed with desperate evacuees. When a strategic objective fundamentally shifts in real time, the physical hardware becomes entirely expendable. In 1945, the overarching strategic objective of the United States shifted practically overnight. We transitioned from defeating the fascist regime of Nazi Germany to actively containing the communist expansion of the Soviet Union. The captured U-boats were simply the physical currency paid to secure that new strategic posture. Despite the mass slaughter of the fleet, the Soviet Union did manage to secure 4 Type XXI submarines through the Tripartite Naval Commission, and the intelligence fallout proved exactly why Winston Churchill and Harry Truman were right to sink the rest. The Soviets took those 4 Elektroboots back to their heavily guarded shipyards in Leningrad and immediately began reverse engineering every single weld, battery cell, and hydraulic valve. The direct result of this technological espionage was the Soviet Project 613, known to NATO as the Whiskey-class submarine. The Whiskey-class was essentially a mass-produced, highly refined Soviet clone of the German Type XXI, featuring the same streamlined hull, massive battery capacity, and deep diving capabilities. Throughout the 1950s, the Soviet Union pumped out an astonishing 236 Whiskey-class submarines, creating the largest single class of submarines built during the entire Cold War. If the Western Allies had not executed Operation Deadlight and Stalin had received his demanded 1/3 of the entire captured U-boat fleet, the Soviet Navy would not have had to wait until the 1950s to field this capability. They would have possessed a massive, combat-ready fleet of advanced hunter-killers on day one of the Cold War, fundamentally threatening the critical sea lanes between the United States and Western Europe during the fragile years of the Marshall Plan. But the United States Navy did not just throw the German technology away and ignore the engineering lessons. The few Type XXIs that the Americans brought back to the Portsmouth Naval Shipyard in Maine triggered a massive fundamental shift in American submarine doctrine. Our engineers dissected the German boats and realized that the future of naval warfare was entirely underwater. This directly birthed the Greater Underwater Propulsive Power Program, classified under the acronym GUPPY. The United States Navy took its massive fleet of surplus Gato and Belau-class fleet submarines, which had just finished strangling the Japanese Empire in the Pacific, and radically modified them. We stripped off their deck guns, removed the external cleats and railings, streamlined their conning towers into sleek sails, and packed their hulls with massive new battery arrays based directly on the German designs. The GUPPY program transformed our sluggish, surface-oriented fleet boats into fast, silent, deep-diving killers. Furthermore, the hydrodynamic lessons of the Type XXI directly influenced the experimental USS Albacore, which introduced the revolutionary teardrop hull design to the world. When the brilliant, uncompromising Admiral Hyman Rickover successfully paired this teardrop hull design with a pressurized water nuclear reactor, the USS Nautilus was born in 1954. The Nautilus was the ultimate realization of the concept that German engineers had desperately tried to achieve with the Type XXI, which was a submarine that never had to surface at all. Does a technological wonder weapon truly matter if you do not have the logistical backbone to fuel it, arm it, and deploy it? The ultimate tactical lesson of Operation Deadlight is the complete and utter failure of the German Wunderwaffe doctrine. The Nazi High Command was obsessed with the idea that a single technologically superior weapon system could mathematically overcome a massive numerical and industrial disadvantage. They poured millions of Reichsmarks and tens of thousands of man-hours into developing the Type XXI, the V-2 rocket, and the Messerschmitt Me-262 jet fighter. But warfare is not a game of top trumps, where the best statistics automatically win the battle. Warfare is a grueling, unforgiving contest of industrial endurance, supply chains, and raw logistical throughput. The Type XXI was arguably the most advanced naval vessel on the planet in 1945, but it was absolutely useless because the German rail networks were shattered, their synthetic oil refineries were burning, and their veteran submarine crews were already dead at the bottom of the Atlantic. The United States did not defeat the U-boat menace by building a better submarine. We defeated it by building a massive, unstoppable logistical machine that flooded the ocean with Liberty ships, escort carriers, and centimetric radar. We won through overwhelming brute force industrial capacity. Operation Deadlight stands as one of the most remarkable, yet heavily obscured naval operations of the 20th century. It was a massive, highly dangerous logistical undertaking that required the Royal Navy to act as the executioner for a defeated enemy's greatest pride. It was an act of economic necessity for a bankrupt British Empire that could not afford to guard or maintain a ghost fleet. But above all, it was a cold, calculated, and deeply cynical opening move in the global chess match of the Cold War. By dragging 116 state-of-the-art submarines into the freezing depths of the Atlantic and blowing them to pieces, the United States and Great Britain ensured that the ocean would remain uncontested while the free world rebuilt itself from the ashes of the Second World War. The steel sharks of the Kriegsmarine were not defeated by their own obsolescence, but by the ruthless, pragmatic foresight of Allied commanders who understood that the weapons of yesterday could easily become the nightmares of tomorrow. The true mastery of warfare is knowing exactly when to build an unstoppable weapon, and knowing exactly when to throw it away. Which factor do you believe was the absolute primary reason for Operation Deadlight? A. Preventing the Soviet Union from acquiring advanced submarine technology. B. The sheer economic cost of maintaining and guarding the captured fleet. C. The tactical danger of accidental explosions and toxic leaks in Allied ports. Let me know your choice and your reasoning in the comments below.